Hello students, this is K. Muraprasad, Department of Computer Science and Engineering, DBS IT, Kavali. Today we are discussing the subject R programming. In that R programming we are in the unit 3. In that unit 3 we are in chapter 2. In this chapter we are going to discuss the topics like formula notation and complex statistics. Here the formula notation is very important for the purpose of complex statistical purpose as well as some of the graphics, etc. This is another form we are specifying especially for the purpose of all the commands which are already taken simply. Now coming to the topics which are available in this chapter are examples of using formula syntax for basic tests. Already we discussed about some of the basic tests like t-test, u-test, paired u-test, etc. For those things we are using some formula notation. The formula notation we are using for the purpose of all the things. Now coming to the formula notation in graphics. This formula notation is also used in graphics. Now coming to the very important one and major part of this chapter is ANOVA, analysis of variance. By using this one, we are analyzing the variance of different samples. What is the variance in one sample and what is the variance in another sample or another vector? By analyzing this one, this concept is called as ANOVA, analysis of variance. How it is varying, how it is similar, what type of things it is varying, what parameter it is varying, etc. Now these are the three different types of concepts here we are discussing in this chapter. Now coming to the first one, examples of using formula syntax for basic tests. Here R program has great analytical power. It is having the analytical power of compared to the very different programming languages like C, C++, Java, Python or etc. The things are usually more complicated. Now coming to this one, you need a way to describe these more complex situations to enable R to carry out the appropriate analytical routines. Here R contains different types of routines or appropriate routines for analysis. R uses a special syntax to enable you to define and describe more complex situations. It is having a different syntax. By using the different syntax, we can easily analyze all the things. This formula syntax permits more complex models to be defined. Now, which is useful because much of the data you need to analyze is itself more complex than simply a comparison of two samples, etc. In essence, you put these responsible, that means a response variable on the left side of the tilt operator and the predictor variables on the right, like the following. Now here we are taking one example, that is a response variable, tilt operator, predictor variable 1 plus predictor variable 2. In this syntax, you simply link the predictor variables using the plus sign, but you are able to specify more complicated arrangements by using the plus sign as well as the asterisk sign and etc. Now coming to the first one, examples of continuation, examples of using formula syntax for basic tests. Here we are using some basic tests. In those basic tests, we are using the formula syntax. Here the first one is the t-test we are taking with the two samples here. T.test of sample.1 comma sample.2. For that simple test, we are using the formula notation, that is t.test of response variable, that is response, tilt operator, predictor, from where we are taking the data, that is by specifying by using the data is equal to instruction. Data is equal to data.name. Now coming to the same thing, same formula notation is also applied for the correlation test or some testing by using the correlate, how much these are similar, etc. cor.test is the command which is especially used to test the what type of correlations are similar, etc. All the things. Now here cor.test of tilt vector.1 plus vector.2 comma data is equal to data name. Here in the first case, you specify two numerical vectors. We want to correlate an individual. In the second case, you are using some formula notation. Now, just we are leaving the blank. Now, left side we are not taking anything, but right side we are taking all the vectors with the plus symbol. Now, here also we can use either plus symbol or asterisk also in the future videos. Now coming to the formula notation in graphics. Already we discussed it. Now already in the last slide, the formula notation are applied for the basic tests like correlation or t-test, u-test or etc. Now coming to the same formula notation we are applying in the graphics also. Now many number of graphical commands we discussed earlier. For those also we are using this one. Formula syntax is an alternative to the basic notation. This makes a link between the analysis and graphical representation or presentation a little clearer and can also save you something, some typing also we can save by using this type of syntax. The box plot of vector 1 comma vector 2. Now coming to the box plot of response variable, tilt operator, predictor 1 plus predictor 2. How we are taking the data means it is specified by using the data is equal to data.name. Now coming to this one. The first case shows that you simply multiple vectors to plot simply by listing them separately in the box plot command. Now coming to the second example, the formula notation where you can specify the response variable in the left side and all the predictor variables in the right side. In the case of simple XY scatter plots, you simply or use the two columns or two options. Here you can use the plot of x dot variable and y dot variable in the simple case. Now coming to the formula notation, we are taking plot of y dot variable, tilt operator and x dot variable, comma data is equal to data frame. Now always it starts with the response variable and then that is the x variable. Now predictor variable is in the x side and response variable is in the y side. Now this is about the formula notation which is available or which is used in the graphics environment. Now coming to the analysis of variables, it is also very important in the examination point of view also. Here this is by specifying one way or two ways or something, the what type of tests we are performing internally here. Analysis of variance is an analytical method that allows for comparison of multiple samples. Now by using this one, we can compare multiple samples. It is probably the most widely used statistical methods and can be very powerful method. As the name suggests, the method looks at variance. Now it is completely based on the variance, comparing the variability between samples to the variability within samples. Now between samples and within the samples, how the variance is varying. Now for the purpose we are using the ANOVA. The formula notation comes in handy. In this case also we are using the formula notation to specify the ANOVA. Now when you have coming to the analysis of variance or linear regression or etc. Now for the purpose of linear modeling or something, we are using the LM is the command we are specifying for the linear modeling. Now coming to the topics which are available in the analysis of variance or ANOVA, that is one-way ANOVA and then two-way ANOVA, comparing ANOVA results with ANOVA command, graphical summary of ANOVA, more complex ANOVA models. Now coming to the one-way ANOVA here, one-way ANOVA, AOV is the command which is used to carry out the analysis of variance. Here we are using AOV command for the purpose of all the things. The simplest form you can use is just like this. The following example shows the simplest data. Here we are taking one data frame which contains all the numerical values. Here, for the purpose of this one, if you use ANOVA like this, now this is not perfect case. Here, the ANOVA is very useful to perform like this as the first column is the numerical data and the second column is the some factor type of things. To create that type of table, the first column is the numerical data and then second column is the some factor type of data. We are using the stack command. Now, how the stack command is behaved and worked, we can discuss in the next slide. Now, here comes to the stacking the data before running analysis of variance. If you are performing the analysis of variance directly, it is meaningless. Now, if you perform the stacking process, after that we can perform the ANOVA or AOV command. The stack command can be used in several ways. If your original data have multiple numerical vectors, you can create a stacked data frame simply by giving the name of the original data. Now here we can use the stack of something. We are take BF as a BF command. Now coming to this one, the stack of the BF something is stack of BF. Now coming to the names of BFS. Now here it produces the values like the two columns it produces. The first column is the numerical values and the second column is the independent variable IND. Here we can take as it is or you can provide some names to those. If you want to provide some names, now the first column is a count command, the count name count, and then the second column is site. You can also provide the names for that also. Now coming to the same thing, running AOV commands. How we are going to run AOV commands? Here bfs.aov is equal to AOV of count tilt operator site data is equal to BFS. Here from the BFS we are taking the data. It contains two sets of columns. The first column is count and the second column is site. Now here dependent variables and independent variables. Independent variable we are taking, that means predictor variables and then response variable. Response variable always available in the left side and then right side variable is the predictor variables. Some set of predictor variables are there. Here if you want to perform the AOV command, the data should be, the right side column should be in the factor format. Now it is very important. Here different types of factors here, arable as well as grass, heath. These are the three different types of factors which are available in the site. Now coming to the extracting means from AOV models. Now here we can take means. Now generally we are performing the effects or variance. We can also extract the means from the models. Different types of models we are taking. For those models we can easily extract the means also. Now what type of command we are using to extract the means here is model.tables. Some set of models we are taking. From those model.tables command we can extract the means. Now coming to this one, first one is model.tables bfs.aov comma type is equal to effects. This is the default one, the effects. Now coming to the second one is we can specify the means externally. If you are not specifying anything, it can directly take the effects also. If you want to take the means or if you want to perform all the means etc., compulsorily you have to use type is equal to means command or means instruction. Now coming to the two-way ANOVA. Here now you have to take into account two predictor variables. You can take two predictor variables also here. So your ANOVA model becomes a little more complicated. You can use one of the two following commands to carry out the analysis of variables for that type. Here the first command is just like pw.aov is equal to AOV of height tilt operator plant plus water data is equal to pw. The second command is pw.aov is equal to AOV of height tilt operator plant asterisk water. Here the only difference is the first command contains the plus and the second command contains the asterisk symbol. That is the main difference. Already we discussed about what is actually the plus means. Now the asterisk represents here is this indicates that you want to take into account interactions between the predictor variables. Now here we can take the normally you can take the variance, but here interactions also we can take if you specify the asterisk symbol. Normally we are taking the variances, but you can take the interactions if you are using the asterisk symbol. Now that is about the very important thing in the second example case. Now coming to the pw.aov is equal to some AOV of here the previous one. Here we comes to plant colon water. Now that is also another one, plant colon water we are taking here. The third term in the ANOVA model is a plant colon water, which indicates the interaction between these two predictor variables. Now here we are performing interaction. The interaction thing we are performing based on the asterisk or as well as coming to the last one, plant colon water. Now based on the plant and water we are taking the interaction. Now you can specify either the previous way or in this way you can specify. Now this is about the two-way ANOVA. Now coming to the comparison of comparing ANOVA results with the ANOVA command. Now already AOV we are using for the purpose of one-way ANOVA or for the purpose of two-way ANOVA. Now these two results are also compared with the another command, that is ANOVA command. ANOVA command. If you have more than one AOV result based on the same data, based on the same data you are having different type of results. You can use the ANOVA command to compare them. Now ANOVA is the command which is used to perform the comparison between the results occurred based on the same set of samples or based on the ANOVA. Now coming to this one, pw.ANOVA AOV1 is equal to AOV of something and then PW of AOV2. These two are from the same data. Now one is from the by taking the plus symbol and one is taking by using the asterisk symbol. Now for that purpose, if you use the ANOVA command ANOVA, it will take the differences or it will take the comparison or it will analyze already the results which are occurred in the same data by using the AOV command. Now this is about the analysis of variance of a particular table. Here we are taking model 1 and then model 2 we are taking. Based on those models, what is the variance, how it is varying, etc. All the things are displayed by using this one. Comparing the ANOVA results with the ANOVA. Already we are comparing these results by using the ANOVA command. Now coming to the graphical summary of ANOVA. Here we can perform the summary or graphical representation of ANOVA also. You should always produce a graphical summary of your analysis. A suitable graph for the ANOVA is the box whisker plot. Already we discussed in the previous classes the box whisker plot. This is also used to provide a summary of ANOVA also, which you can produce using the box plot command. The instructions you give to this command to produce the box plot mirror, those you can use it to carry out the ANOVA process or AOV. Now here the commands are pw.aov is equal to AOV of height tilt operator plant asterisk water, comma data is equal to pw. Here you can use simply the box plot of previous one. Box plot of height tilt operator plant asterisk water comma data equal to PW. CEX dot axis is equal to something. We are specifying some axis also here for the purpose of this one. In the X direction, we are taking interaction, and in the Y direction, we are taking the height. Now that is about the X label as well as Y label. Here also we can perform interaction plots. Now how they are interacting by using the interaction dot plot command. We are also performing the interaction plots. It can often be useful to visualize the potential two-way interaction in an ANOVA. You probably are the interaction plots, actual running analysis. You simply visualize the situation using interaction plots via the interaction dot plot command. The basic form of this one is interaction dot plot of x dot factor or comma trace dot factor and response variable. Now this is about the syntax we are using for the purpose of graphical summary of ANOVA also. Now coming to the last topic in this one is here more complex ANOVA models. Now you can ANOVA models are we can create different complex models. So far we have looked at the fairly simple analysis of the variance, one way and two way. Now we can discuss about the one way as well as two way. You can use the formula notation to create more complex models on occasion demands. Now we are also using the formula notation also. In all the cases, you place your response variable to the left of the tilt operator and put your predictor variable to the right side. Now we specified like this. We are placing the response variable in the left of the tilt operator and predictor variable in the right of the tilt operator. In these examples, y is used to represent the response variable. In all these operations, y is especially used for the purpose of response variable. It is a continuous variable, and x represents a predictor in the form of continuous variable. It is also a continuous variable. It is specified in the x direction. Uppercase A, B, C represent the factors which discrete levels, that is a predictor variable. Now we are using the capital letters like A, B, C, especially for the purpose of all the things. Now this is about the more complex ANOVA models. We can also specify more complex models like by using the plus symbol, by using the asterisk or etc. Now with this we are concluding or we are specifying or we are discussing ANOVA. It is very important analysis of variance. Now analysis of variance is carried out within the sample or between the two samples. Now some complex analysis also were performed. Now in this analysis of variables, we are specifying the methods directly or by using the formula notation.